Today we're talking still about inequalities, but this time they are called compound inequalities. So in my little paragraph here, it says compound inequalities are two inequalities combined together. A compound inequality containing the word "and" is only true if both inequalities are true. The graph will show the two inequalities overlapping. The place of overlap is called the intersection of the two graphs. Okay, so these examples at first are going to look pretty weird. If we look at example 1, there's really two inequalities here. There's an inequality right here that says 3 is less than or equal to x, which also can be written as x is greater than or equal to 3. And then we also have an inequality right here, x is less than 7. So this just separates into two inequalities where the first one is anything before that inequality symbol, and the second one is anything after that first inequality symbol. So then we can graph this. We have a closed dot at 3 going to the right, and this time we're just going to shade a little bit for right now. And then x is less than 7, so open circle at 7. This one's going to the left, so my shading is just going to be in between two numbers. So this means x can be anything between 3 and 7. Okay. For example 2, it says solve this and then graph it. Now there's two different ways to solve this. One way is to separate it into two problems. So here's my first problem. So -2 is less than or equal to x minus 3. And my second problem is right here. X minus 3 less than 4. So again, it just separates where the inequality symbols are. So if we solve this, we get add 3 to both sides to get 1 is less than or equal to x, which really means x is greater than or equal to 1. And then we can also add 3 here to get x is less than 7. So I see I have an open circle on 1 going to the right, and again just shade a little bit to the right for right now. Open circle on 7 going to the left. So I see I'm going to be shading between 1 and 7. Now the other way to solve this, if I rewrite the problem over here, normally anything by the variable you do the opposite. So instead of minus 3, I'm going to add 3 to every single part. So -2 plus 3 is 1. Bring down your inequality symbol, bring down your x. -3 plus 3 is 0. Bring down your inequality symbol, 4 plus 3 is 7. So here I can see my two problems. One is less than or equal to x, and x is less than 7. So I get the same answers. So you can choose which way you prefer. Sometimes if the problem is a little bit more complex and there's more terms, I would recommend doing it the first way. But if it's a simpler one like this, go ahead and do it this way. It's fine. Okay, moving on to the next page. Example 3, they were nice enough to write the two inequalities separate for us. So we're just going to solve each one. Add 3 to both sides to get y greater than or equal to -8. Solve the other one. Add 3 to both sides. Y is less than or equal to -5. So we have a closed circle on -8 going to the right, and a closed circle on -5 going to the left. So you're shading in between the -8 and the -5. Make sure I can see if the dots are open or closed. If I can't tell, I'm going to count it wrong. Now, the next part, another type of compound inequality contains the word or. A compound inequality containing or is true if at least one of the inequalities is true. So we're going to graph both of these. They're already separated for us. So we have x is greater than 2. So open circle on 2 going to the right. This time you can go ahead and shade all the way. That's fine. And then x is less than or equal to -1. So closed circle -1. This one's going to go to the left. So notice that the shading goes away from each other. That's fine. Okay, moving on. Next, we are going to solve both of these. So I'm going to subtract 7 from both sides on this problem to get negative 2m less than or equal to 6. Divide both sides by negative 2. Since I divide by a negative, I need to flip that sign, get negative 3. And then the other problem, subtract 12 from both sides to get 5m greater than 25. Divide both sides by 5 to get m is greater than 5. So we're going to have a closed circle on negative 3 going to the right. But we also have an open circle on 5 also going to the right. So it's going to look like this. And I don't want you to shade through the open circle, so make sure I can still tell that it's open. Okay. I believe this is the last one. Okay, so I'm going to subtract 1 from both sides to get a is less than 3. Add 1 to both sides to get a greater than or equal to 4. So we have open circle on 3 going to the left and closed circle on 4 going to the right. So it should look like that. So we're still solving inequalities the same way. Yep, that was the last one. Just we have 2 that we graph, and that's okay. If you have any questions, please let me know.